Tell us your name and tell us about your project. My name is Ernest Rutherford. The project you're asking about is the Gieger-Marsden experiment, commonly known as the gold foil experiment. It was conducted at the University of Manchester in the span of 4 years between 1908 and 1913. What were you guys trying to do or find? We were trying to test the accepted model of the time, which was Thomson's plum pudding model. This model pictured atoms as a spread out blob of positive charges with electrons scattered through it. We wanted to see if the particles' paths matched what the model predicted by firing alpha particles at thin gold foil and observing how much they scattered. Where did the project or experiment occur? The experiment took place at the University of Manchester in England in my physics laboratory. What other significant events were happening around the world at that time? Around 1908 to 1913, Europe was building toward World War I. There were alliances, an arms race, and the Balkan Wars, while the suffrage movement pushed for women's rights in Britain and the US. It was also a golden age for science, with Einstein developing relativity and Marie Curie winning her second Nobel Prize, alongside major tech shifts like Ford's Model T and early aviation. Who else was involved in the project? The two key collaborators in this project were Hans Geiger, a German physicist, and Ernest Martin, a young undergraduate student at the time who did much of the hands-on counting scintillations, and of course myself, who directed the research. What was your role in the project? My role was to direct the whole experiment. I designed the experiment, firing alpha particles at gold foil and watching how they scattered. I left the daily observing to Geiger and young Martin, but I set through tasks and interpreted what came back. When Martin reported some particles bouncing almost straight back, I knew we had found something incredible. That told me the atom had a small, dense, positive center and had a diffuse cloud of charge. It was now my job to turn the observation into the new model of the atom. What impact did your project have on the physics community? The impact was enormous. It overturned Thomson's plum pudding model entirely, showing atoms of a tiny, dense, positive nucleus surrounded by mostly empty space. This became the Rutherford model, which I believe will lay the foundation for nuclear physics. What was the biggest challenge you faced during the project? The biggest challenge was the precision it demanded. Geiger and Martin spent hours in total darkness, straining their eyes to count faint flashes, especially at wide angles we expected to be empty.